Hi, this is Sung. I'm the Principal and Director of Sky Academy, and in this episode what we're going to be doing is continuing on our work with the relationship between roots and coefficients for a polynomial with a string of terms, all in the degree of x. Okay, so for example, now we're up to the stage where we're going to be doing a question, and the example that I've chosen is this. Solve the equation 2x cubed minus 21x squared plus 42x minus 16 equals 0. That's the polynomial, given that the roots form consecutive terms in a geometric sequence. All right, so ordinarily, all right, the roots of an equation will be alpha, beta, and gamma, right? All right, especially if it's to the order of 3, if it's a cubic. So there'll be 3 roots, alpha, beta, gamma. All right, so in other words, the sum of the roots one at a time would be minus beta on alpha for alpha, beta, gamma. All right, and if it was a quartic, so in other words, a polynomial of the degree 4, and there were 4 roots, then it would be alpha, beta, gamma, delta, right? So the sum of the roots one at a time, or alpha plus beta plus gamma, would be minus beta on alpha. Or sorry, not minus beta, minus b on a, not minus beta on alpha. Does that make sense? The sum of the roots 2 at a time would be alpha beta plus alpha gamma plus beta gamma. Okay, so alpha beta plus alpha gamma plus beta gamma. Got it? Sum of the roots 3 at a time. So in other words, that would be the product of the roots, which would be alpha, beta, gamma. And I left a third one there, a fourth one there, so I can't count today, but I left the fourth one there, which is the sum of the root 4 at a time, and that would apply for quartics and above, right? So in other words, any polynomial to the degree 4 and above, then it'll have 4 at a time. Degree 5 and above would have 5 at a time, 6 at a time, 7 at a time, etc. Okay, but for the sum 3 at a time, it'll just be these 3 there because it's cubic. Okay, now what's special about this particular example is we're told that the roots will form a geometric progression. Yes, so in other words, if one of your roots is alpha, let the roots be alpha. The root to the left would be alpha on r, which is your common ratio, and your other root would be alpha times r. Does that make sense? Which would be your other common ratio, your other root, which would be the other term. Okay, so in other words, you've got one term where you're dividing by a common ratio and one term where you're multiplying by a common ratio, and you've got the middle term alpha. Does that make sense? That's going to make things a little bit easier as we do this question. Got it? All right, so in other words, they're your 3 roots. So in other words, alpha plus alpha on r plus alpha r is going to be equal to, sum of the roots one at a time, it's going to be 21 over 2. Does that make sense? Sum of the roots 2 at a time, which is alpha squared on r plus alpha squared r plus alpha squared, yes, because that's the product 2 at a time, is going to be 42 on 2, which is 21, yes, and the product of the roots is going to be alpha cubed, because alpha times alpha is alpha cubed. This r cancels with that r, so they disappeared. So the product of the roots 3 at a time, or the product of the roots, is just equal to alpha cubed, which is going to be minus negative 16 on 2, which is just 8. Does that make sense? All right, what does that tell you about a? A is going to be either positive or negative, whoops, I'll write it this way, positive or negative 2. Does that make sense? So let's test each of those 2 out. So I'll stand over to this side, all right? What does P of plus 2 equal? All right, let's work this out. So it's 2 outside of 2 cubed minus 21 2 squared plus 42 times 2 minus 16. That's going to be equal to 16 minus 84 plus 84 minus 16 equals to 0. So in other words, 2 is one of the roots. X, which means x minus 2 is a factor. X is equal to 2 is a root or a 0. All right, let's try p is equal to negative 2 now. This time we've got 2 outside of negative 2 cubed minus 21 outside of negative 2 squared plus 42 times negative 2 plus 16 minus 16. That's going to be equal to negative 16 minus 84. Is that right? 84. Yes. Minus another 84 minus 16, which is not going to be the answer. Yep. So in other words, that's going to be equal to minus 200. X plus 2 is not a factor. So we've worked out that x minus 2 is a factor. What we need to do is we've got to work out what our other roots are. Okay, so let's have a look at how we might do that. We can pretty much solve simultaneously now, and let's have a go at doing that. Let's put x is equal to 2 into each one of these. So we put 2 into that. That's equation 1. That's equation 2. Equation 1 comes 2 plus 2 on r plus 2r equals 21 on 2, which ends up being, let's have a look, 1 on r plus r equals to 21 on 4 minus 8 on 4, which will be, which minus 4 on 4, which will be 1 on r plus r equals to 17 on 4. All right, equation 2 should become the same thing. All right, so equation 2 becomes, so it's 4 on r plus 4r plus 4 equals to 21. Bring the 4 over to the other side and then divide by 4. So let's do that. So 4 on r plus 4r equals to 17. 1 on r plus r equals to 17 on 4. So now, this is an equation that is really a quadratic in disguise. We're going to multiply both left and right hand side by r, and it will become a quadratic. So let's do that. So multiply both sides by r. 1 plus r squared equals to 17 on 4r. Multiply both sides by 4, and you get 4 plus 4r squared is equal to 17r. 4r squared plus 17r, it should be minus 17r, plus 4 equals to 0. R becomes 4r1, 4, 1 minus minus. R ends up being 1/4 or 4. All right, so in other words, that's not what we want. We don't want r equaling 1/4 or 4. What we want to do is multiply r by alpha, which is 2. Yep. So your alpha is going to be, where is it? So what's 1/4 of 2? It's a half. And what's 4 times 2? It's 8. Okay. So your 3. So let me go over on this side, and we'll work out the answer. Basically, what you've got is AR. So your roots, are going to be 1/4 times 2, which is going to be a half. One of your roots is going to be 2, and your other root is going to be 8. Does that make sense? And so each of these this ratio is going backwards and this ratio is going forwards, all right? So one of the ratios is your ratio for your sequence of terms going forward. The other one's for the sequence going backwards, okay? That's why you got two ratios. So you got a half, 2, and 8. So in other words, your answers to this, so basically your answers to this are x minus a half, x minus 2, x minus 8, all to the power of 2 equals, all times 2 is equal to 0. And the reason why it's times 2 here is because your a is 2, all right? So in other words, x will equal a half, 2, and 8. That's your solution for this equation. And what I will do is I'll basically show you how this curve will look like, how this polynomial will look like if you were to graph it. So in other words, if you were to graph y is equal to 2x cubed minus 21x squared plus 42x minus 16, it will look like this, all right? Your y-intercept is going to be negative 16. Your roots are going to be a half, 2, and 8. So I will stand to the side, let you take a snapshot of this, and then I will graph it for you. Okay, so welcome back. I'm now going to graph what this curve will look like. Now, this, let me just say, it's not part of the question. It's not part of this question, but sometimes you'll be given that in a question sketch, and then therefore part 3 of a 3-part question might be sketch the curve y is equal to that polynomial. Okay, so the only reason why I'm going through the sketch of it is so that you might be able to do a question that involves sketching it. Okay, so let's have a look. All right, so we know that our roots are a half, 2, and 8. Let's say a half is there. Let's say 2 is there, and let's say 8 is over here. We know that the y-intercept is negative 16, all right? Because you put 0 into the equation, and that gives you x equals to 0 into the equation, that gives you a y-intercept. So minus 16, if we were to draw it to scale, minus 16 would be way down here, minus 16. Yep. What you notice is that none of these roots are double or triple roots, so that they will run smoothly. Okay, so what's going to happen is this curve is going to run from negative 16 up to minus 2 in a nice smooth curve. It's going to kind of turn back round, go through 2, and turn back round and come through to 8. Now, we don't know where the highest and lowest points are, and the maximum and minimum points, but using your knowledge of advanced maths, okay, we can work out the turning points or the stationary points and the nature by using the first derivative, making the first derivative equal 0 and solving for x, right? Working out the y coordinates by substituting into the formula. And then working out the nature of those points, either by testing points on either side or going to the second derivative and testing whether it's positive or negative to work out the concavity. Okay, so they're the two ways that you can work out the maximum and minimum points using your mathematics knowledge, your 2-unit mathematics knowledge. But let me just show you how to graph the polynomial, assuming that there's going to be a maximum here and a minimum there, because there will be. Okay, so it's going to go up like that, turn back down, and then go through 8 like that, okay? Now, like I said, I'm not going to go through where the maximum and minimum points are. That's a totally different topic, but you should be able to work that out, okay? Now, I want you to know that that's the polynomial that we've got down here. So let us label it, because that's the other thing we need to do. We've labeled the major points. Okay, and we just need to label the curve now, which is this curve up here. Good. All right, thank you very much for watching. Bye.